As I explained in the last lecture, when writing your own functions, prefer not to raise exceptions because these exceptions come with a cost. And that's what I'm going to show you in this lecture. So from the timeIt module, I'm going to import a function called timeIt. With this function, we can calculate the execution time of some Python code. So this is how it works. Imagine we want to calculate the execution time of this piece of code. We define a variable, let's call it code1, and set it to a string. This string should include our Python code. So I'm going to use triple quotes because our Python code is spread across multiple lines, and we terminate it here. So this is one piece of code. Now, after that, we call timeIt. As the first argument, we pass our Python code. That is our code1 variable. Now here we have a keyword argument, number. We set this to the number of times we want to execute this piece of code. So let's set it to 10,000 so we can see the difference. Now this function returns the execution time of this piece of code after 10,000 repetitions. Now this function will execute our Python code 10,000 times. It will calculate the execution time and return it. So we can simply print it on a terminal. I would like to add a label as well. Let's say first code. Now, open up the terminal window. You can run this using code runner. So type Python app.py. You can see our program was executed 10,000 times, and we got 10,000 messages here, and here's the execution time. Now to clean this up, let's go back to our except clause. I don't want to print this error message, so let's use the pass statement. This pass statement is a statement that doesn't do anything. And we need to use that here because we cannot have an empty except block. Okay? So save the changes. Back in the terminal, let's run this one more time. So here's the total execution time. Now let's try a different approach. Back in our calculate x factor function, instead of raising an exception if age is 0 or less, we can return a value like none. So I'm going to select this entire code, copy it, then paste it. Let's change this variable's name to code2. In this implementation, instead of raising an exception, we want to return none. So none is an object that represents the absence of a value. In this new implementation, we don't need a try block, so we can simplify our code. Let's delete that, as well as the except clause and the pass statement. We simply get the x factor. We can store it in a variable. So instead of handling an exception, we can compare this x factor with none. So if x factor equals none, then let's just pass. So immediately you can see this code is simpler than the previous implementation. And as you will see in a second, this will be executed almost 4 times faster. Let me show you. So down the bottom, I'm going to duplicate this line, change the label to second code, and replace code1 with code2. Save the changes, back in the terminal, let's run the program. So here's the execution time of the first implementation. As you can see, our second implementation was almost 4 times faster. Now there is a caveat here. We see this difference when we execute this piece of code 10,000 times. So if you run the code once, you're not going to see any differences. In other words, if you're building a simple application for a few users, raising exceptions in your functions is not going to have a bad impact on the performance of your application. But if you're building an application where performance and scalability is important, then it's better to raise exceptions when you really have to. As a general rule of thumb, when you want to raise exceptions in your functions, think twice. See if you can handle the situation with a simple if statement. Whether there is a performance difference or not, your code will end up being a little bit cleaner. So, raise exceptions if you really have to.